Hi, welcome to Algebra 2 Common Core. Today in lesson number 4, we're going to take a look at the normal distribution and how we can apply z-scores to evaluate how far away a certain score is from the mean in terms of the standard deviation. So the normal distribution can be used in increments other than half standard deviations. So in the past lesson, we used a diagram of the standard curve, of the normal distribution curve, and we said that we could divide that to the left and to the right of the mean by half standard deviations. And it was symmetric with respect to the mean. But we're going to see in this lesson and the next lesson how we can actually do calculations other than just a half of a standard deviation away. So we have to define a new score that's called a z-score. So the z-score is going to be calculated by taking the data point, taking the x value, and subtracting the mean, and then dividing by the standard deviation. In essence, all this does is figure out how many standard deviations the data point is away from the mean. So it's going to be positive if the data point lies above the mean, or the z-score will be negative if the data point lies below the mean. So just a couple new terms here and some new notation. First of all, we see that we're using a different symbol for mean. This is called the mu symbol. Mu is a Greek letter of the alphabet, and it stands for the mean of our data. So instead of using x bar, we use mu. The standard deviation is going to be our lowercase sigma, so that's going to be the population standard deviation. And we're going to be calculating the value for z. So let's take a look at example number 1. It says that boys' heights in 7th grade are normally distributed. So again, it's really important that we see those words, normal distribution, with a mean height of 62 inches. So that's going to be our mu value to calculate the z-score. And a standard deviation of 3.2. So that 3.2 is going to be the standard deviation for this problem. We want to find the z-scores rounded to the nearest hundredth for each of the following heights. And of course we'll show our calculation that gives us that answer. So I've drawn a picture of the normal bell curve so that we can kind of get a feel from our last lesson of what is happening in this problem. We see first of all that the mean score is 62, so that's right in the middle, and the standard deviation is 3.2. So every time I go up a standard deviation, I add 3.2 to my score. And every time I subtract the standard deviation, that's giving me the score that's 1, 2, and 3 standard deviations below the mean. So we're talking about a height of 66 inches. So we can kind of look at this and say, well, 66 inches is going to fall somewhere around here. But we want to know exactly how many standard deviations that's going to be. I know that it's got to be bigger than 1 standard deviation, but smaller than 2, and it looks like it's going to be a little bit closer to 1. So let's go ahead and do the calculation to tell us that z-score. So z is going to be equal to my score, 66, minus the value for the mean, which is 62, divided by the standard deviation, 3.2. Now be careful when you enter this on your graphing calculator. You're going to want to enclose the numerator in parentheses. And I want to give this answer to the nearest hundredth. This, in fact, comes out to be exactly 1.25 standard deviations above the mean. And that answer, of course, makes sense to us because we could see that 66 is going to be bigger than 1 standard deviation, but closer to 1 than it is to 2. Let's try part B. For part B, we've got a height of 57 inches. So the z-score for 57 inches will just equal 57, my score, minus the mean, 62. So again, that's calculating how far away from the mean I am. And when I divide by the standard deviation, 3.2, that's going to tell me how many standard deviations I am away from the mean. Z is going to be equal to negative 1.56 rounded to the nearest hundredths. Now let's see where this score would be on our normal distribution curve. 57 inches means that I'm right here between 1 standard deviation below the curve and 2 standard deviations below the curve. So somewhere in here is that score of 57 inches. That's also why our z-score turned out negative, because I'm below the mean. Whereas in part A, my z-score was positive because I was above the mean over here. So let's go ahead and figure out the last example here. To find the z-score for 70 inches, we're going to say 70 minus 62 divided by 3.2. And again, if you think about that, it just means I want to know the distance the score is away from the mean, and then divide by the standard deviation to find out how many standard deviations it is above the mean. In this case, I'm getting an answer of exactly 2.5. So if I look at this, I say, okay, 70 inches, that's going to be between 68.4 and 71.6. And in fact, it turns out to be halfway between those two. So that's why I have a half in my standard deviation. So 2.5 standard deviations above the mean. This next example, number 2, allows us to see the importance of z-scores. Z-scores are really very helpful anytime I have a comparison where the standard deviations and the means don't match. I can still find out how well a student did on a test, for example, by basing it on the z-score. So in example number 2, it says that Lauren is enrolled in a very large college math class. On the first exam, the class mean was 75 and the standard deviation was 10. On the second exam, the class mean was 70 and the standard deviation was 15. Lauren scored 85 on both exams. So on which exam did Lauren score better relative to the rest of the class? So without z-scores, it's hard to figure out whether that 85 means the same thing or something different on these two tests. So let's divide this work up and talk about exam number 1 and exam number 2. So with exam number 1, we know that the mean was equal to 75, so that's my mu. And we know that the standard deviation was equal to 10. So we can calculate what Lauren's z-score was on that test by saying her score was 85. So her z-score will be 85 minus 75 divided by 10, which of course I see that she was exactly 10 points above the mean. So 10 points above the mean is telling us because 10 is also the standard deviation, she was 1 standard deviation above the mean for that test score. Now let's look at exam number 2. For exam 2, we know that the class mean was 70. Maybe that was a harder test. And we know that the standard deviation was equal to 15. Lauren still got a score of 85, so let's calculate her z-score for this test by saying 85 minus 70 divided by 15. Well, when I do the calculation, I see that her z-score is still equal to 1. So regardless of which exam I'm looking at, she got the score of 1 standard deviation above the mean for both tests. So what that tells us is that choice 3 is correct. She scored equally well on both exams because in both cases she got 1 standard deviation above the mean. That was her z-score. In example number 3, it says Jeremiah took a standardized test where the mean score was 560 and the standard deviation was 45. We know that Jeremiah's score gave him a z-value of 1.84. So we want to know what was Jeremiah's score to the nearest whole number. So notice that this time in our calculation, I've got my formula z is equal to the score minus the mean divided by the standard deviation. We are given that the mean score was equal to 560 And we know that his standard deviation for this test was 45. And we also know that his z-score was equal to 1.84. So if we substitute those values in, that's going to allow us to solve for the x in my formula. So I'm going to say 1.84 is equal to x minus 560 divided by the standard deviation 45. Now this is just a proportion that we can solve by cross multiplying. So we want to go ahead and multiply 45 times 1.84, and that's going to be equal to x minus 560. So 45 times 1.84, I'm going to get that answer, and then I'm going to add on 560. So I get that Jeremiah's score must have been 643. So I can calculate any of the variables given 3 of the others. In example number 4, we're comparing prices. So the prices of the printers in a store have a mean of $240, so that's our mu, and a standard deviation of $50. The printer that you chose costs $340. So what is the z-score for the price of your printer? So I'm going to calculate z by taking the cost of our printer, $340, and subtracting the mean, $240, and then dividing by 50. So basically our printer was $100 higher than the mean. So when I take that 100 and divide by 50, I see that my z-score is equal to 2. Now to interpret that answer, let's go to part B. How many standard deviations above the mean was the price of your printer? So we are paying 2 standard deviations above the mean. So we're paying quite a bit more for our printer compared with the average printer. In example number 5, we have another height example. So Andrew's height is 63 inches. The mean height for boys at his school is 68.1 inches. So we're going to say our mean is equal to 68.1, and the standard deviation is equal to 2.8 inches. So we want to know what is the z-score for Andrew's height when we know that Andrew's height is 63 inches. So the z-score would be equal to 63 minus 68.1 divided by 2.8. And we want to round this answer to the nearest hundredth. Now, clearly we can see that because Andrew is shorter than the average height, my z-score is going to be a negative value. So again, make sure that when you're doing this calculation, you put parentheses around your numerator. So we're getting an answer of negative 1.82. So what is the meaning of this value? It just means that Andrew's height is 1.82 standard deviations below the mean. Height. And again, a z-score is going to be helpful in describing data because we can more easily compare data. Even when the mean and the standard deviation don't match. In example number 6, you're going to be given a chance to calculate how normal are you. According to the Centers for Disease Control, the mean height for teenage boys in the United States is 68.6 inches, and the mean height for teenage girls is 63.8 inches. The standard deviation for boys' heights is 2.8 inches, and the standard deviation for girls' heights is 2.6 inches. So first of all, depending on your gender, sketch the normal model. So make your bell curve and fill in the numbers for the height with the standard deviations. So label those standard deviations on your bell curve. Then go ahead and calculate the z-score for your height. So make sure you come out and tell what your height is, and then find the z-score. And lastly, interpret what that z-score means in reference to this problem. So we'll be looking at those answers tomorrow in class. So be sure to do these calculations for example number 6 for your specific height. Thanks very much for working tonight on z-scores. We're going to continue z-score calculations and how we can use them to then find probabilities tomorrow on our next video. Have a great night and we'll see you next time. Bye-bye.